Hey, Algebra 1, this is page 3 of the Unit 2 review. And I'll go ahead and get started. Okay, so the first question here is we're going to write the number of tiles for each figure in this table. Okay, so remember in the notes we had to find the missing figure. We don't have to do that here. We just have to figure out the pattern and figure out the equation for that pattern. Okay, so figure 1, if I count them out, 1, 2, 3, 4, 5, 6, 7. Okay, then the next figure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then the next one has 1, 2, 3, 4, 5, 6, 7, 8, 9, plus the 4 gives us 13. So now I take figure 1 and put it under the 1. Figure 10 goes under the 2 for figure 2. Oops, sorry. Okay, and then figure 3 goes under the 3 for figure 3. And now I recognize right away the pattern is going by plus 3, plus 3, plus 3. So now I just have to fill in the rest of the table. Okay, so the next one would be plus 3, 16, plus 3, 19, plus 3, 22, plus 3, 25. Okay, and then the one before that, well, if I'm going by plus 3, that means I go minus 3 here to go to 4. So now we filled in our table, and now we're going to create an equation with that. Okay, so the equation is going to be y equals, and then we're going to have a number times x plus another number. Okay, so if you remember, the first number, let's actually pick a new color here, we'll use pink. The first number is going to be the pattern. Okay, so the pattern here is plus 3. So we're going to put 3, or positive 3. And then the last number is going to be the starting point. Remember, the starting point in this case was 4. That's what the pattern starts with. So that's what's going to go here. So it's y equals 3x plus 4. That's our equation. Now the next question says, explain the meaning of t to the t of 3 equals 12. Remember, in this problem, the 3 is the input, or the figure number, and 12 is the output, and in this problem, the number of tiles. Okay. Now the next question says, find t of 30. So in other words, the input, or the figure number, is 30, and we need to find the output, okay, or the number of tiles for figure 30. Well, we're going to use our equation for that. Okay, so we use the equation. Equation will be y equals 3 times, because remember we're going to use parentheses for that 30, and we'll just put that right there, because this is our new function, our equation. 30 times 3, actually let's write it like this, t of 30, because remember that's what we're looking for, equals 3 times 30 plus 4. Okay, so first we do 3 times 30, which is 90, plus 4 is 94 tiles. Okay, and you can put that here for your answer, 94 tiles. Okay, so now Frank thinks that figure 50 has 154 tiles. Decide whether he's correct and justify your answer. Well, I can simply just use the equation and figure out how many tiles does figure 50 have. Okay, so I'll set up my equation. Now, if we're talking about figure 50, then that would be t of 50. Okay, and then we'll just plug in 50, so 3 times 50 plus 4. Well, 3 times 50 is 150, plus 4 is 154, so Frank is correct. Okay, and that is our justification. It's just figuring out the math. Okay. Okay, now that's this one, graph behavior. We need to figure out all these different parts of the graph. Okay, so first let's talk about what's going on with this graph. First of all, we have a point here to the left, and then on to the right we have an arrow. So that means this graph stops here at this point, but to the right it keeps going forever. Okay, so let's keep that in mind. Okay, now for the minimum, that would be the lowest point. Okay, now the lowest point on this line is this point here. And it doesn't go down forever. So that means it actually stops here. And the low, remember, minimum is the y value, and lowest, so that's -2. Now the maximum is the highest point. Now we would say this is the highest point, but this is an arrow, so that means it keeps on going forever and ever and ever. There's no top. Okay, so there, here we just say none. Okay, x-intercept, where does it cross the x-axis? Well, first, let's write this. We'll write the parentheses in comma because we're looking for a point for both x-intercept and y-intercept. Okay, for the x-intercept is where it crosses the x-axis, and it crosses here at this point. And if you can't read that numbers, we'll just count it. 1, 2, 3, 4, 5. Hamsa. Okay, so the x is 5, and that means the y is 0. Where does it cross? Now y-intercept, that's where it crosses the y-axis. Okay, so that's here at this point at the bottom. Okay, so then that is -2. And the y is -2, so that goes second. And the first one would be 0. Okay, so if you're looking for the x-intercept, you put in the x value, the other value is 0. Y-intercept, you put in that number here in the y, and the other number will always be 0. Now, is this increasing or is it decreasing? So remember, as we go to the right, what is the function doing? And right now, it's going up, or it's increasing. So simply just say it's increase. Now, a domain, again, like we on the first page, we start from left to right, or negative to positive. We first say, is this function going to the left forever? No, it's not. There's no arrow pointing this direction to the left. It's stopping here, right at this point. And remember, we're talking about x, and x at that point is 0. And now to the right, does it go forever? So to the left, 0. To the right, yes, because this arrow points to the left forever, and to the right forever. And to the right forever is positive infinity for x. Now remember, around a number, we put a square bracket, and around infinity, we put a parenthesis. Okay, now range is pretty similar. Remember, we start from the bottom to the top, or negative to positive again. So in the bottom, use a different color here. The bottom, it does not go down forever. It stops right here at that point again. And that point for y, remember range is y, is -2. So we'll write -2. And then we say, does it go up forever? Yes, it does, because this continues to go up and up and up, as you can see with that arrow. And going up forever is positive infinity. Okay, and remember, around the number, we put a square bracket, and around the infinity, we put a parenthesis. Okay. Okay, and that's it for page 3. Go to the next video for page 4.